Okay, so this video won't be too long. Our focus is now using energy to make predictions, okay? And so I'm going to give you two examples, and we'll kind of walk through the process of how we can use the tools that we have to now solve for things. And so in this first example, we have this object that is, we'll say it's a block with a mass of 10 kilograms, and it's dropped, and it falls some distance, 20 meters, and we want to find out how fast it's going when it hits the ground, or how fast it's going once it's fallen these 20 meters. And so what we can do is so if you remember, we can actually use kinematics to figure this out. We know the initial velocity, we know the vertical displacement, we know that it's going to experience acceleration from gravity, so we can write those things down and solve for final velocity. Okay, we can also use energy here though. Okay, so if we approach it from an energy perspective, we can make a chart, or we could say, okay, well, it has height at the beginning, so we can say, well, we started with gravitational potential energy then. And afterwards, it's lost that height and gained speed, so that means that our gravitational potential energy was transformed into kinetic energy. So now we have kinetic energy afterwards. Okay? So we can use this to write an equation. We'll say m times g times h is equal to 1/2 mv squared. And now we can solve for the velocity. Okay, we know we can substitute in the mass, but you can see it's on both sides, so we can divide it out. But we'll go ahead and substitute. So say 10 kilograms times 9.8 meters per second squared times a height of 20 meters will be equal to 1/2 times 10 kilograms times v squared. Okay, so I'll simplify this, and we're going to get 19.8 meters per second. Okay, so you can see I multiplied all these together here. I multiplied 1/2 times 10 there. I divide this over, and then I take the square root. Okay, and I end up with 19.8 meters per second from solving all that. Okay, and that's really it. That's how we could use energy here. And sometimes maybe it doesn't make sense to, like this might be something where it'd be easier to use kinematics, but sometimes it does. Okay, and the next one is the situation that we would not be able to solve using kinematics. Okay, so this is a continuation of that problem that we've been working on in class, where there's the roller coaster going over the loop. Okay, and so we're going to look at how fast it's going when it's at the top of the loop, and let's say that it is 10 meters up. Okay, and so the question is, how fast is it going when it gets there? And so the first step will be to make charts. Okay, and we'll see that we're compressing a spring, and it's going to cause this cart to move and go up to there. So if we have a compressed spring, that means we're going to start with elastic potential energy. Okay, which is going to transform into kinetic energy and gravitational potential energy. Okay, so we have it in these buckets here at the end. And we know that elastic potential energy was transformed into kinetic and gravitational potential energy. Okay, so we can write an equation, 1/2 kx squared for elastic potential energy. For kinetic energy is 1/2 times m times v squared. And then for gravitational potential energy, that's mgh. Okay, so from here now, I can actually go in and substitute these values. So for example, the mass I was given is 500 kilograms, so I can put that in for m. The strength of the spring, which is the k value, is 500,000 newtons per meter, and the stretch is 0.5 meters. So I say, okay, 1/2 times 500,000 times 0.5 squared is equal to 1/2 times 500 kilograms times v squared plus 500 times 9.8 times our height of 10 meters. Okay, and so we'll simplify all this. Okay, we simplify each of these, so 0.5 squared times 500,000 times 1/2, 1/2 times 500, and then 500 times 9.8 times 10. Now from here we have a pretty simple equation to solve. We need to subtract this from both sides, 49,000 from both sides, Okay, and then we'll get 13,500 equal to 250 v squared. And the last step will be to divide by 250, and then to take the square root, and then we're going to get a velocity of about 7.3 meters per second. So that means that's how fast it's going at the top of that loop. Okay, and so here's us using an LOL chart, an energy to make a prediction. Okay, and later when we look at thermal energy, we're going to see that in cases where energy is lost, we can solve for how much energy is lost, or we can kind of make predictions. It will get a little bit trickier though when we try to make predictions with energy loss. Okay, please let me know if you have any questions.